Hey everyone, here's the next video for our practice test. I wanted to go back for a second. Ms. Sessions had accidentally forgotten to show the balanced chemical reactions for question number 3. So go ahead and pause the video at this point if you would like to check your balanced chemical reactions. Continuing on with question number 14, sodium metal reacts with water to produce sodium hydroxide, according to the following equation. So the first thing I always do is look to see if the equation is balanced, and clearly with some 2's in front here, it looks like the equation is already balanced for us. So how many grams of sodium hydroxide are produced if 20 grams of sodium react with excess water? In this reaction, we're told that the water is excess, so therefore the sodium by default has to be the limiting reagent. We don't have to do any additional calculations to figure that out. So we always start with the amount given in the problem, which is 20 grams of sodium, and we must convert sodium to moles. Using the periodic table, we find sodium's molar mass, which is 22.99 grams per mole, with grams canceling. If we stop there, we'd have the moles of sodium, but of course we want to relate it to sodium hydroxide. Working diagonally, I need to relate the moles of sodium to the moles of sodium hydroxide. I use the balanced chemical reaction in a ratio of 2 to 2. 2 moles of sodium hydroxide are produced for every 2 moles of sodium metal consumed. I know it seems a bit redundant, or I should say useless, to put 2 over 2 in the equation. However, we always go through this formal step just to make sure, because it's not always going to be 2 over 2. Those ratios may change. So rather than leave them out, we just always include them. If I were to stop here, I would have the moles of sodium hydroxide, but of course, the question asks me for grams, so I need one more step. How many grams of sodium hydroxide are in 1 mole? I add up the weights of individual 1 sodium, 1 oxygen, and 1 hydrogen, and you should get 40.00 when you add all of those elements' weights together. The only unit that does not cancel is grams of sodium, so we're done. On my calculator, I take 20 divided by 22.99. I can ignore the 2 over 2 and multiply by 40. That gives me an answer of 34.8 grams of NaOH. What is a limiting reagent in a chemical reaction, and what is a reagent in excess? Which determines how much product is formed and why? The limiting reagent determines how much product is formed because it's the reagent that runs out first and therefore stops the reaction. How much product you get, therefore, is determined by the amount of the limiting reagent you have to start with. The reagent in excess is the reactant that's left over when the reaction stops. Turning to question 16 on the back, 3.5 grams of H3PO4, which is phosphoric acid, and 3.50 grams of KOH are dissolved in distilled water and reacted. I always check to make sure it's balanced first, and looks like that's already done. How many moles of H3PO4 and KOH are there at the start of the reaction? Well, if I have grams, I need to convert those grams to moles. The moles at the start of the reaction is not 1 and 3. Those are the ratios in which they combine or react, not their starting amounts. So if I take 3.50 grams of H3PO4, I can convert that using the molar mass of H3PO4. I add together the weight of 3 hydrogens, 1 phosphorus, and 4 oxygens to give me 98 grams per mole. And that leaves me with 0.0357 moles of H3PO4, phosphoric acid. How many moles of KOH are there to start? I have the same starting grams of KOH, but here I must use KOH's molar mass. Potassium hydroxide. Adding together 1 potassium, 1 oxygen, and 1 hydrogen, I get a molar mass of 56.11 from the periodic table, leaving me with 0.0624 moles of KOH. The easiest way to identify the limiting reagent is to actually take your starting moles of each substance and compare that amount to the coefficient in the balanced chemical reaction. What this tells me is that one H3PO4 molecule reacts for every 3 KOH molecules. What you do is you divide the H3PO4 by the number 1, which is its coefficient in the balanced chemical reaction, is one way to do this. And then I, of course, get 0.0357 moles of H3PO4 back. Notice, though, that the KOH has a 3, which means that the KOH is actually consumed at 3 times the rate. So if I take the starting amount of KOH and divide that by 3, and when I do that, I get the value of 0.0208 moles of KOH. And whichever number is smaller is the limiting reagent. Another way to do this would be to pick a product. For example, one of the products is water. You can relate the starting amount of each of these substances to the same product. Whoever gives you less of that product will be the limiting reagent. Notice that this step involves an additional relationship on top, right? You're relating it to water, but the same denominator is true as in my example. So in either case, you find that KOH is the limiting reagent. So we identify KOH as our limiting reagent, and our reagent in excess is H3PO4. The last problem asks us to calculate the mass of the potassium phosphate that forms. Write the final answer. Now, if you choose this method above, you do not start with these values, but instead you begin with your starting value of the KOH. If you were to use this value, you would end up double dividing by the number 3. So we always start with our beginning moles of our limiting reagent, which is 0.0624 moles of KOH. And from there, we want to relate the KOH to our product, potassium phosphate, which is K3PO4. And to get this relationship, we look back to our balanced chemical equation. 1 mole of K3PO4 is produced for every 3 moles of KOH consumed. And we need to convert that final mole to grams. So how many moles of K3PO4 per gram of K3PO4? And again, we're going to use the periodic table whenever we have a mole mass relationship. And we use the periodic table to determine that 3 potassiums, 1 phosphorus, and 4 oxygens would have a mass of 212.27 grams. So we use our calculator to take 0.60624 divided by 3 times 212.27, and we end up with a final mass of 4.42 grams of the potassium phosphate.